Good evening, everyone. Myself Sridhar, and I'm from CSCF section. And for the AAT Tech Talk on the subject computer networks, my topic is about an empirical study of 5G effect on the edge of transport protocol and application performances. Here we can see the introduction to 5G technology. The 5G is a fifth generation of wireless communication standards offering higher speeds and lower latency. It enables new applications such as IoT, autonomous vehicles, and smart cities. Understanding 5G's impact on network protocols and applications is crucial for optimizing the performances. Here, the introduction to the 5G technology, where the 5G is the fifth generation uh, fifth generation wireless communication standards, which is offering the highest speed and with the low latency. Where the latency is nothing but the time taken to complete the uh, like the complete those networking. So hence here we can it enables the new applications such as IoT, autonomous vehicles, and the smart cities. And it's also the crucial for the protocols and the network protocols, and it's crucial for optimizing the performance. And also motivation for the study. The deployment of edge computing in 5G network promises to reduce latency and improve efficiency. There are limited empirical data on how edge influences transport protocols and application performance. This study aims to fill the gap through the real world measurements and analysis. Here are some of the things such as the deployment of edge in the edge computing in the 5G networks are like promising to reduce the latency and improves the efficiency. Uh, Research objectives. Here are some of the objectives for the research on the 5G to evaluate the impact of edge computing on transport protocol performance in 5G networks, to analyze how edge influences application latency, throughput, and reliability, to provide insights for optimizing 5G network and application design. These are the objectives, where the first objective is to evaluate the impact of edge computing on the transport protocol performance in 5G networks, and to analyze how edge influences application latency, throughput, and reliability, to provide insights for optimizing 5G network and application designs. And the key concepts and definitions. The 5G network utilizes advanced radio access and core infrastructure for enhanced connectivity. Edge computing involves processing data closer to data source, reducing transmission delays, and also the transfer protocols like TCP, QUIC play a vital role in managing data flow and performance. Here the key concepts for this 5G is to utilize the advanced radio access and also core infrastructure for enhanced connectivity. And also useful in the edge computing involves processing data which is closer to the data resources and reducing transmission delays. Methodology overview. The study employs empirical measurement from real world 5G edge environments, data collection, and includes throughput, latency, and packet loss metrics for various protocols. Experiment compare edge-enabled and traditional cloud-based configuration. Here you can see the methodology overview, where the study employs the empirical changes with the 5G edge environments, and also the data collection includes the throughput. The throughput is nothing but the value we are getting, and the latency, which is nothing but the time which is taken to get this all the 5G network, and also the packet loss metrics for various protocols. And then we are comparing the edge enabled and traditional cloud based configurations. And then we are like going for experimental setup, uh, where a test bed with 5G base station, edge servers, and client devices was used. Different transport protocols TCP, QUIC were tested under various load conditions. Application scenarios included video streaming, file transfer, and real-time communication. Here, the experiment is to have a test bed with a 5G base stations, Edge servers and client devices were used, and also to transport these from transport protocols are such as the TCP and QUIC were tested under these load conditions. And then the application scenarios includes video streaming, file transfer, and also real-time communication to check the network speed and empirical speeds of the these file transfer, video streaming, and also the real-time communication. And then impact of edge on transport protocols. There is a huge impact of edge on the transport protocols, such as the edge computing significantly reduces latency for TCP QUIC connections. The QUIC demonstrate better performance in higher latency edge-enabled scenarios. Protocol adjustment are necessary to optimize performance in the presence of edge architectures. Here we can see that the impact where it significantly reduces the latency for TCP and QIC connections, and also the enabling the performance, demonstrating the better performance in high latency for the QIC and edge enabled scenarios. And these protocols adjustments are necessary to optimize the performance in the presence of edge architectures. Then the application performance results. Application latency decreased noticeably with edge deployment, enhancing user experience. Throughput improvements were observed in data-intensive applications. Reliability increased due to localized processing and reduced network congestion. Here we can see that the application latency is like decreased noticeably as the edge development, enhancing user experience. These throughput improves were observed in data-intensive application. Reliability increased due to localized processing and reduced network congestions. Comparative analysis. Edge-enabled 5G network outperform traditional setup across key performance metrics. QoIC outperformed TCP in terms of latency and throughput in edge scenarios. The benefits are more pronounced for latency sensitive and real-time applications. Here the comparative analysis are such as like edge-enabled network, 5G network for outperforming the traditional setup for the across the any performance metrics and all. This is the most benefit is like pronounced for latency sensitive and real-time applications. Challenges and limitations. The variability in edge resources availability can affect the stability and performance. Security concerns arise with distributed edge processing. Further research is needed to optimize protocols for diverse edge environments. Here are the challenges where the most important challenge is to variably change the edge resources and the available effect stability and the performance. The security arises only when the distributed edges are processed. Implication of network and application design. Developers should consider edge-aware transport protocol for optimal performance. Network operator need to strategically deploy edge resources for maximum benefit. Application can leverage edge computing for enhanced responsiveness and reliability. And you can see the some of the which are like future research direction. Investigate adaptive protocol tailored for dynamic edge environments. Explore AI-driven network management for 5G edge networks. Study integration of 5G edge and with other emerging technologies like AI and IoT. The most important, the future research directions such as the investigation of the adaptive protocol tailored for dynamic edge environments. This is the investigation where which has been done for the dynamic edge environments where these protocols are tailored, and then the explore AI driven network management for 5G edge networks. We are here uh, exploring the AI driven network management for any 5G networks and like edge networks. Study integration of 5G edge with other emerging technologies like AI and IoT. Here the study will integrate with the AI and also the IoT devices. Conclusion. Edge computing in 5G networks significantly enhances transfer protocol efficiency and application performance. Empirical data confirms reduction in latency and improvements in throughput and reliability. Strategy deployment of edge resources is critical for maximizing the 5G capabilities. Here you can see the edge servers are receiving from the base station to the base station, which is under during using the core network and also clouds. And also we having the edge server cloud type. This is the process we have to do in by using this edge servers to maximize the 5G capabilities. And this is all about the topic. Thank you.